Okay, we'll be taking a major one. Oh, Taylor boy. This Taylor series expansion of functions of two variables. Oh, Taylor series is a very beautiful topic. Oh, very beautiful. It's not hard. In fact, I didn't just want to write down there's a derivation for this series. Now you use this series. You use this series when you have a a function with continuous terms that you can keep on differentiating. Let's say sine x. Differentiation of sine x will give you cos x. Differentiation of cos x will give you minus sine x. Differentiation of minus sine x will give you minus cos x. Differentiation of minus cos x will give you sine x, like that. So it keeps on going. Same as maybe exponential x. Differentiation of exponential x, you keep on differentiating. It's the same thing. It's the same thing. So when you have cases like that, you can um, expand those cases using Taylor series. So let's just this is the main series now. When I say it's main series, I mean it's something you should know how to derive. You should. I think I learned how to derive it, but maybe after learning I now knew some things to take note of and how the position should be. So you have f of x comma y is equal to f of a plus b plus you have a big bracket here plus bracket x minus a partial f of a comma b all over partial x plus partial y plus y minus b partial f a comma b all over partial y. When we explain this, you're going to understand why I have partial f a comma b. It's just like you're having maybe you're giving z is equal to something. This is actually partial z over partial x at a comma b. That's what this means. This is partial z over partial f or partial f over partial y at a comma b. So when you've gotten it now, they'll give you they'll give you a and b usually in this form, or they'll tell you a is this and y is this, or they'll give you in powers of x minus a and y minus b. So you know where your a and b is. Then we have for the second order, so these I think zero order is zero order because there's no partial f here. This first order, the power of the derivatives is 1. This second order, the power of the derivatives are 2. So I don't know, I guess I will likely, okay, let me see if I can explain how I get it here. So you're looking at it already. Please be sure to pause it and take note of everything here. Be sure to pause it and take note of everything so that I can explain. There's no need calling it out. I'm sure you can see it already. This x minus a square, the square f of a comma b all over the x square plus 2x minus a y minus b, the square f over dx dy plus y minus b square, the square f over the square f of a comma b all over dy square plus 1 over 3 factorial. This is for third order. This is for fourth order. Yes. So how do I get this expansion? I know the zero order. Zero order is sorry, this is not a plus b, this is a comma b. The zero order is f of a comma b plus the first order. Now from the first order I will get the other orders. So the first order is x minus a partial f a comma b all over partial x plus y minus b partial f a comma b all over partial y. I know the zero order, I know the first order. Now let's get the second order. The second order starts with 1 over 2 factorial. I guess here it can be 1 over 0 factorial. 0 factorial is 1. 1 over 1 factorial. 1 factorial is 1. So the next one is 1 over 2 factorial. That's 1 over 2 times 1, which is 1 over 2. Now we square everything. So like the next order is the square of this one. Recall when you have what do I want to use? You have x plus a square. You're going to have x squared plus 2xa plus a squared. I see. This expansion alone is our is what will determine the second order. But now I don't really carry expansion, so I just wanted to show you, like when you square this. So okay, let me use this one first. When you square this, you have x minus a. X now is x minus a, so you have x minus a squared. When you square this, you're going to have the f square over the x square, the square f over the x square, plus how do I explain it? Okay, plus 2xa. X is x minus a is y minus b, so plus 2x minus a y minus b. If you remember binomial expansion, when I was studying binomial expansion, that's how I used to do my expansion. I used to call it like you're carrying powers, you're carrying over powers. So now the first power we have here is this, the square f over the x square. For the next term, I carry one power from here and give it to the x dy, so that both of them will now become powers of 1 and 1. That's the next term. For the next term, I take one power from x again, so the powers, they are moving from left to right. So I take one power from x, so x now be 0 and y will be 2. That will be the next one. Whereas for the constant is a square, so a is y minus b, so we have minus y minus b and bracket y minus b square f over the y square. Now for the third order, you may not really start doing x plus a raised to power 3. If you recall Pascal's triangle is 1, then 1 1. Is Pascal's triangle is for coefficients of the expansion. Then you have 1 2 1, you have 1 3 3 1, you have 1 4 6 4 1. It gives you the coefficients. So for the third order, we are working with these sets of coefficients. We are working with this sets of coefficients 1 3 3 1. So now for third order, it's going to be 1 over 3 factorial. The first term, I come back to the first order. See, I know since the third order, the highest power now should be 3. So I give this one x minus a raised to power 3. I give this to 3 and 3. For the next, this thing now, what is here? The coefficient is 3, so I bring down 3. I move a power from this one to this one. I take out one power. This has 3. When I take out the power, I give this one, kind of like I give this one life, so I bring this one into the equation, and then this will be left with 2. Also with the x has 3. I take out one power and give to this man, so this will be 2. So it gives us our next equation to be 3x minus a square y minus b d raised to power 3 partial raised to power 3f a comma b all over partial x square partial y. From here now, I know that the next thing that will come, the coefficient is 3, so I bring down 3 again. You see, I bring down 3. I'm working with this. I bring down 3. I take out one power again. So as we are going, for every plus, there's a giving out of power from the former to the latter, right? So I take out one power to this guy. This one will be left with 1 x minus a. This guy will have 2 y minus b square. From here, I'll give out one power again to this guy for the next term. So this will now become the x, the y square, and then the coefficient of the last one is 1. So I take out the final power and give to this guy. This guy will now go out he will go out. So you'll be left with y minus b raised to power 3. I'm just thinking like how I to derive it so that I don't really cram it. So we have y minus 3 d raised to power 3 f a comma b all over. I take out the final power and give to this man. You have the partial y raised to power 3. Then for the fourth order, I just decided to do it because even to test myself, because the one I have stopped in the third order. So let me try fourth order to is it like proofread my, or how do I like test run my own this method of getting this, and I guess it works. So for the fourth order, it starts with 1 over 4 factorial. I come back to the first order, I give this guy 4, this man have 4, so that's it. The next this thing is using coefficient 4, so I bring down my 4. I give this from 4 here, I give this guy 1 power, so this x minus a is left with 3, y minus b will now have 1. The x have 4, so I take out 1 and give to the y, so you have partial x raised to power 3 and partial y. The next term is 6. From the previous one, this guy have 3, this guy have 1. I take out 1 again and give to him. Both of them now have 2. I take out 1 from here and give to this guy. They have 2 now. The next term is 4 brackets. They have 2. I give this guy 1 again. It's now 1 and 3. Then this doesn't change for each of them depending on the order. So you have d raised to power 4 f a comma b all over. They have 2. I give out 1 again, the x dy raised to power 3. And then for the last term, the coefficient is 1. I take out the final one and give to this guy. So this guy is out of the equation. We have 4 here, y minus b raised to power 4, d raised to power 4 f a comma b all over. I take out the final one and give to this guy, the y raised to power 4. So you can do it up to the fifth order. The fifth order will be 1, 5, 10, 10, 5, 1. Like that. For the coefficients, then you know how you give out the powers to get the terms. So that's it for how I expand my own from binomial expansion. Alright, so let's take an example. Expand x square y plus sine y plus exponential x in powers of x minus 1 and y minus pi using Taylor series up to terms of second order. So we're going to stop here at this bracket, second order. Alright, solution. You're giving f of x comma y is equal to x squared y plus sine y. Okay, so we equate this to f plus x exponential x. Now I told you they either give you as a is equal to this or y is equal to this, or they give you in a bracket. So x minus 1, we know that our a is 1, we know that our b is pi. So f of a comma b is equal to f of 1 comma pi. Then therefore f of 1 comma pi, substitute where you see x put 1, where you see y put pi. That's what I did, and you have pi plus sine pi plus e to be your f of 1 comma pi. It's part of it too. So why are we doing it? Is because the first term for Taylor series f of a comma b, our a is 1 and our b is pi, so we have to get it. So we go to f of 1 comma pi. Now the next term, we need the square, the f over dx, we need the f over dy. We will need the square f over dx square. We need the square f over dx dy and the square f over dy square. So we need 1, 2, 3, 4, and 5. So let's solve for those 5 now. The f dx from here is going to be 2xy plus exponential x. 2xy, this is 0, this is exponential x. So recall I told you you're having the f a comma b, so that's the f dx at a comma b. So at a comma b, our a is 1, our b is pi. So at 1 comma pi, you substitute, and this is the answer. This is what you're putting in your Taylor series expansion. The f dy is x squared plus cos y. This is 0. at 1 comma pi, you put it, this is what you have. The square f over dx square is going to be 2y plus exponential x. When at 1 comma pi, you have 2 pi plus e. The square f over dx dy, that's dx dy differentiated with respect to x, you're going to have only 2x. This is 0. At 1 comma pi, you have 2. The square f over dy square, these are dy, differentiated with respect to y, you have minus sine y. This one is 0. At 1 comma pi, just y, so you put pi there, minus sine pi, sorry. Now, substituting into the Taylor series expansion, once you know the expansion, once you've written out the expansion, then you just need to substitute into it. So f of x comma y is equal to f of 1 comma pi. We put f of 1 comma pi plus x minus a df dx at 1 comma pi. That's this. So we have x minus 1, 2 pi plus e plus y minus b df dy at 1 comma pi. Are you seeing this? That's the Taylor series expansion plus 1 over 2 factorial brackets x minus e square. The square f over dx square, the square f over dx square at 1 comma pi, that's this, plus 2x minus a y minus b, the square f over dx dy at 1 comma pi, that's 2, plus y minus b square, we call b is pi, so y minus pi square bracket, the square of over the y square at 1 comma pi, that's this. Now pi is 180 degree. Pi is 180 degrees, so sine 180 or sine pi is 0. So you have pi plus 0 plus e exponential 1. Recall you've been having exponential x. X is 1, so you can do if you're using Casio, there's a button there. The button that will give you pi when you press shift. When you use alpha on that same button, it's going to give you exponential. So check the value of alpha exponential and when you use the normal exponential 1, they are the same thing, so you can just leave it as exponential instead of putting that 2 point something. So you just put it as this sine pi is 0, exponential plus, you look here, cos pi is minus 1, cos 0 is 1, cos pi over 2, which is cos 90, is 0, then cos pi, which is cos 180, is minus 1. So here is minus 1, so 1 minus 1 is 0, so this is cancelled out. Let's enter here. It's just analysis now, trying to get the simplest form. This is not even the simplest form, but this is an okay form. There are some questions we were given as assignments. We had to break it down, like pieces, the Taylor series expansion, break it down fully till like you get an answer, happy. So that's we just leave it here. This is okay. So we are going through it. We can even remove this 2 factorial. We know 2 factorial is 2 times 1, so this is 1 over 2. When you open something like this, now you open this one, you open this square, so the 2 now can cancel out. So there's a lot of things going on here, but not for now. When you're doing your own, you can do those stuff. So let's open this. Okay, we have this is okay. 2 times 2 give us 4. Minus sine pi is 0, so this is also cancelled out. So our final form is f of x comma y is equal to pi plus exponential plus x minus 1, 2 pi plus exponential plus 1 over 2 x minus 1 square, 2 pi plus exponential plus 2 times 2, 4 bracket x minus 1 y minus pi. This is out, so this is an okay form for it. So that's how you use Taylor series. So once you know the expansion, you can do the expansion. You just get the values you need, all the differentials you need, solve for it, then at the points you're giving or the powers you're told to raise it to, you just put it there and you get it.